Hi everybody, in this video we are going to be talking about unit 13.2.1, which is finding the slope of a line. And then I would maybe highlight this because we are doing this section out of EdReady's order. So if we are covering this topic, so if this topic is coming right after coordinate plane, then if you're looking in the graphing unit, finding the slope of the line is going to be a couple topics down. So I think it goes coordinate plane and then graphing, and then it does slope, and then it does writing the equation of a line. So just make sure you're paying attention to the order there so you don't accidentally do the practice problems and the check your knowledge test for the wrong topic. So just be careful there. All right. So the slope of a line, our first kind of just definition we're going to fill in there is what is the slope of a line? And the slope of a line is used to describe the steepness and the direction of a line. So the steepness and the direction of a line. It is also considered a line's rate of change. So how fast is it changing and in which direction is it changing? So it's the rate of change. So is it increasing? Is it decreasing? So it's our rate of change between our y values and the x values, and it's represented by the letter m. So let me give you an example. Sometimes we might have a slope and it's something like our rate of change is going to be -2/3. And so the steepness is described by this ratio, by the 2/3. And so if we're doing, let's say we've got the point, I don't know, like 0.4 up here. And so we've got this point 0.4, and I say, well, the rate of change is -2/3. Well, we haven't gotten to this yet, but I'm just going to show you like how this works. Our rate of change says, okay, if we've got this point on our line, the next point down is going to go down to right 1, 2, 3. And then we would graph that point. And then we'd go down 2, and it would go right 1, 2, 3. And then we would graph our line between that. So that is showing your rate of change, because it's like this rise over run in between your 2 points. And so that's how it's showing your rate of change. So it's showing the steepness, like how steep is this line, and also the direction. It's going down and to the right. And so that's what our slope is telling us for a graph of a linear equation. All right, so here's some different ways usually that we express our slope, like different ways that we can describe our slope with this letter M. So one way we describe it is we're saying we're finding the difference between our two y values over the difference between our two x values. Well, we use that formula when I would say, like, let's take 2 points and we've got the points 1, 5 and -2, 7 or something. And I would say, okay, find the slope between those 2 points. Well, then we would say, okay, let's just set this up, and we're going to say that this is your x1 and our x2, and this one's going to be your y1 and your y2. And again, remember from a coordinate plane that we talked about, these are our ordered pairs that are in the order of x, y. And it does not matter at all whether you had said, well, maybe I want to make this one x2 and this one x1, and then I want to make this one y2 and this one y1. So it doesn't matter that part, but what does matter is that if you say that this is x1, then this one has to be y1. So the ones have to be together in the same ordered pair, and the twos have to be together in the same ordered pair. So just like the twos are together here and the ones are together here. So that's how it does matter. So in that case, if we are using this formula to find our slope, I would say, okay, well, let me take if I'm doing y2 minus y1, I'm going to do y2 minus y1. So I'm going to do 7 minus 5 all over x2, negative 2 minus 1. So I'm going to do negative 2 minus 1. So then up here, I'm going to get 7 minus 5 is 2. And then I'm going to get negative 2 minus 1, which is negative 3. And so my slope on that one is going to be negative 2/3. So that was totally coincidence that I ended up with the same one that I gave you over here. But it's going to end up giving you the slope of negative 2/3. So that's one way where we use that formula. By the way, you can also write it like this. You can say, or you can write it as y1 minus y2 all over x1 minus x2. So you can write it like that too. All right, another way to write it is that we would write a triangle, and that triangle symbol is actually called a delta. It's a delta symbol, and that delta means change in. So it's a Greek letter, delta, and it means change in. So oftentimes you're going to see me abbreviate the slope like that because I'm going to say, let's find our change in our y over our change in our x. Because we're finding, we're finding the difference between our two y values over the difference between our two x values. Another way to find this is graphically, we might calculate our slope by finding the rise over the run. So we're going to do this on a different page, but where I say, I actually give you the graph and I say, okay, I want you to find the rise over the run. So I want you to find the, the difference between the y values here versus the difference between the x values here. And we would find our rise over our run. Finally, we might also describe it as our vertical change over our horizontal change. All right, so we've got 4 types of slope. We've got a positive slope. And that's when the graph of our line is going up and to the right. So it's going up and to the right. So it's gonna be like this. It's going up and to the right. So this is positive. So it's going upward right. And then our negative slope is our next one. Negative slope, and it's a graph of a line with a negative slope. It's going to slant downward right. So downward right. And it's going to look like that. And so this one is negative. And what I like for you guys to do is to think about like taking your finger and taking your finger across the graph from left to right. And so if I take my finger and I'm just kind of dragging it from left to right, and then if I hit this line, and again, I'm going from left to right, and I hit that line, and then I take my finger and I hit the line and I keep going to the right, I'm going up. And so that helps me remember like, okay, am I climbing up the mountain? Am I going down the mountain? I'm going up the mountain. And so I've got a positive slope, just like on a treadmill, right? Like you change the grade or you change the slope. You say, okay, I want to work a little bit harder today in my workout. So I'm going to increase the grade and I'm going to increase the percent. And so you're climbing up that hill. So take your finger, go across, you hit it, you go up. Same thing with the orange line. So this time I'm going to take my finger, go across, I hit the orange line, and now I'm still going from left to right, and now I'm going down. Going down the hill, it's down, it's a negative slope. So here's our next slope. Our next slope is a 0 slope. So we've got a 0 slope, and then we've got a graph of a horizontal line has a 0 slope. So think about that. Like if I've got a horizontal line here, again, go back to our treadmill example. If we get on our treadmill and we do nothing to it, like we just get on, we hit the start button, that's a 0 slope. We haven't increased the slope. We haven't decreased it for like those fancier treadmills. It is 0. We're just walking straight across. it's a zero slope. So just again, if we're talking about our guy going up the hill, or a little guy here going down the hill, it's a negative slope. Going straight across, that's a zero slope. We haven't gone up, we haven't gone down, that's zero. Versus if I put one in here and it's a vertical line, and our guy is all of a sudden like hanging here, and he's dropping and he's yelling undefined words. Ah! So it's not a zero slope, it's an undefined slope because our guy is falling, yelling undefined words. That's a graph of a vertical line. And it has an undefined slope. All right, so now we're going to practice finding our slope. We're going to practice finding our slope several different ways. We're going to calculate it between two ordered pairs. We are going to find it from a graph, and then we're going to find it from an equation. So this first way, we are going to find it using our formula, and it's going to be m equals, and I kind of wrote in my space there, but it's going to be m equals, we can either use y2 minus y1 all over x2 minus x1, or we can do y1 minus y2 all over x1 minus x2, or we can do change in y over change in x. Those are all the ones that we can use for finding our slope between two ordered pairs. So let's say for our first one, I don't know, it doesn't really matter. Let's say we're going to use this slope. This is the one you guys have probably seen most often. And then typically what you guys do is then say, okay, well, this is going to be my x1, y1, and this is going to be my x2, y2. Now use your formula. So it says take y2 minus y1. So I'm going to do take y2, negative 4, minus y1, which is 3. Then I'm going to do my x2 minus x1. So here's my x2, which is 0, minus x1, which is 5. And I'm going to get negative 7 up top, all over a negative 5 in the denominator. Negative over a negative is going to give me a positive, and it should be positive 7/5. And that is your slope. And sometimes I get the question of, well, what if I do the other formula? Am I going to get the same thing? Like, what if I did this formula, Liz? What if I got y1 minus my y1 minus y2? Well, let's check that out. So if I did that, and I did y1 minus y2 instead, and I did 3 minus a negative 4, and then I'm going to put that all over 5 minus 0. And so then I'm going to get 3 minus negative 4 is 3 plus 4, which is 7, all over 5 minus 0, which is 5. And that still gives me positive 7/5. So you can do it either way. All right, I'm going to bump over to 3 because it's just simpler because it's right there. Same level for me vertically. This time I'm going to do change in y over change in x. So change in y over change in x, I just think of it as like, all right, I'm going to start with my y's, and I'm going to go from left to right. This is my change in my y. So I'm going to do 1 minus 1. And then I'm going to do my change in my x's. And if I went from left to right for my y's, I have to go from left to right for my x's. So I'm going to go negative 5 minus a negative 3. So 1 minus 1 is going to give me 0. Negative 5 plus 3 is going to give me a negative 2, which again, 0 over negative 2 is just a 0. So that's a 0. What type of line has a 0 slope? And if you don't remember, go back up and look. What type of line up here has a 0 slope? It's a horizontal line. So this means we've got a horizontal line with our slope of 0. So this is our slope of 0, and we got a horizontal line. Well, I'm going to make it go, I'm going to have you guys go one step further here. So our horizontal line, our horizontal lines, we're going to write it as like our equation for horizontal lines is always like 100% of the time, always going to be y equals some constant term. We'll look back at our ordered pairs. What's the number that was always the same, that was constant, that was always the same? It's the 1. And it's in what position, the X or the Y? The Y position. And so that means 100% of the time for this equation, our Y's are always going to be at 1. Well, why is that? Because it's a horizontal line at Y equals 1. Like, look at this. If I graph the point -5, 1, it's going to be -1, 2, 3, 4, 5, -5, up 1. It's going to be right there. The next one, -3, 1. -1, 2, 3, up 1. It's going to be right there. So then if I determine, okay, that's a horizontal line at Y equals 1. Come over here. I have no idea what this X is, but look up. What's that? So my X value is going to be some positive X. What's my Y value? It's going to be 1. We know that. So that is why our equation is Y, because our Y's are 100% of the time always what? They're equal to 1 for this equation. Okay, so let's look at the next one. Use whatever formula you want. You can use this one, you can use this one, you can use this one. So I tend to use the change in my Y over my change in my X's. It's faster to write. I'm going to do -5 minus 5. This is my change in my Y's. So -5 minus 5 all over 2 minus 1. This is my change in my X's. 2 minus 1. So I'm going to get -10 over 1. And -10 over 1 is just -10. And so there's my slope. So this is your slope. Let's try the next one. So my slope is going to be my change in my Y over my change in my X's. So I've got my change in my Y, which is going to be -1 minus 8. So this is my change in my Y. My change in my X's is going to be 7 minus 7. Uh-oh, I'm going to get a 0 in the denominator. So I've got -9 over 0. What happens when we get a 0 in the denominator? What is, like, mathematically, what does that mean? Is that a 0 or is that something else? Now you can even try it in your calculator if you're not sure. Do -9 and divide it by 0. And what do you get? You get an error because it's undefined. This is undefined. This is my slope too, right? My slope equals this because it equals this. It equals -9 over 0. And then that means that it's all undefined. What type of line has an undefined slope? Go back up and look if you're not sure. Remember, this guy is yelling undefined words because he's falling. It's a vertical line, has an undefined slope. Well, guess what? If a horizontal line starts with Y equals some constant term, what do you think a vertical line is? It's going to start with X. It's going to be X equals some constant term, right? So look back at your values up here. What is the constant that is repeating, that is constant? It is 7. And what position is it in? It's in the X position. Because our equation for this type of line is X equals C. It's X equals some constant. And in this equation, what is it? It's X equal, what is the constant that repeats? It is X equals 7. So here's our slope. Our slope is undefined. I want you to go a step further and give me the equation of that line. And the equation of our vertical line is going to be X equals 7. And think about that, like come back. Let's draw a little postage stamp graph and you can prove it to yourself, like 7, -1. So 7 is going to be 1, 2, 3, 4, 5, 6, 7, 7, -1. And then 7, 8 is going to be way up here. And then if we were drawing that line, okay, that's a vertical line. I have no idea what this ordered pair would be, but I know it's some, I know our X value is going to be +7. And I know that my Y value is some positive Y value. But 100% of the time, I always know that, like, what's this point? It's 7 positive Y. What's this point down here? It's 7 some negative Y. 100% of the time for that line, my X's are 7, which is why our equation for a vertical line is X equals some constant. And in this case, because the X's repeat here at 7, it's X equals 7. All right. Let's look at finding the slope from a table or a graph. So we're going to do the same thing from a table, just like we would do for any ordered pairs. So pick 2 ordered pairs. I'm going to pick something with the 0 because that's pretty easy. So I'm going to pick this ordered pair and pick any other ordered pair. It doesn't matter. Pick any one you want. I'm just going to pick the top one for kicks and giggles. So my change in my y's are going to be on this side. I went from top to bottom for the y's, so I need to go from top to bottom for my x's. That's going to be my change in my x. So I am going to have 10 minus 0 all over -5 minus 1, which is going to give me 10 over -6, which is going to give me -5/3, because you want to reduce that. So we're going to take a 2 out of both of them. So that's our slope. And let's find out what happens with the y's. And maybe you already see this. Maybe you're like, oh, the x's are repeating. What happens when we have x's that are repeating? That's a vertical line. So what kind of slope is that? That's an undefined slope. So again, pick any 2 ordered pairs you want. I'm gonna pick those 2. You could have picked like these 2 as well. And now that I've written my arrows there, I'm just gonna do that. So we're gonna do change in y over change in x. It doesn't matter. We're gonna get the same exact slope. So I'm going to do 7 minus 10 all over 11 minus 11. And that's going to give me -3 all over 0. I've had students ask me before, wait a second, let's say they did like 11/5 and 11/10, and then they would get 5 minus 10, which is -5 over 0. And they're concerned about this is -5 and this is -3. But guess what? They're both over 0. So when they're both over 0, what do you get? You get undefined for this one, and you get undefined for this one. So again, what type of line gives you an undefined slope? So you're going to write undefined slope, and then you're going to go one step further. You're also going to write the equation. Our equation starts with x equals something for a vertical line, and then look at your table. X always equals what? X equals 11. So for this one, our equation is x equals 11. All right, so now let's talk about how we find it from a graph. So graphically, here's what I would like for you to do. I want you to find 2 good lattice points. And lattice points means, let's find out where our graph crosses a good crossing point on our grids. So for example, looking at graph number 6, it looks really close to -1, 1, but look, does it cross perfectly right at -1, 1? No, really close, but it's not there. So where's another good crossing point? To me, it looks like we've got a good point right here at -3, -4. And then it kind of looks like to me like the next one might be all the way up here. But let me see. Let's see if we're off at all. So that means I'm going up, because we're going to draw a triangle here. That's what I want you to do. Identify 2 good crossing points. Now draw your triangle. And let's see if we might be able to find any other ordered pairs in between there. So the way we figure that out is we are going to figure out what our rise over our run is. So our slope again is going to be rise over run. So let's figure out what it is. 1, 2, 3, 4, 5, 6, 7, 8. So that went a rise of 8. And what's it running? 1, 2, 3. And then again, ask yourself, is it going up and to the right? Is it going down and to the right? Or again, you can take your finger, go from left to right. Now we hit it, and now we're going up. That's a positive slope. So our answer is 8/3 for that. So our slope is positive 8/3. Let's try this one. So we're doing m equals rise over run. Find 2 good crossing points, 2 good lattice points. I'm seeing one right here. Where might another one be? There's another one here. Looks like another one right here and another one here. So you could pick any 2. Like you could have maybe picked this one and this one. And let's draw our triangle between it. So if we draw a triangle between those 2 points, our rise over our run, it's going to be up 1, 2, 3. Oh, I got off. 1, 2, 3, 4, 5, 6. That's 6. And then 1, 2, 3, 4. So my rise over my run is 6/4. Is it positive or negative? We're going down into the right. So that should be negative. And now reduce. That's going to be -3/2. -3/2. And then if you want, draw a different triangle. You can go like this. You could have gone like this. I get that question too. What if I draw my triangle down, Liz? Is that okay? Sure. So we're going down 1, 2, 3, right, 1, 2. So maybe you did it that way, and that's -3/2. It's the same thing. All right, let's try some more. If you guys want, pause the video as well, and then check it back at the end and see if you did it right. On every single one of these, I should see some sort of show work or a triangle or something. For this one, for a horizontal line, and also this vertical one, I also want you to write your equations for those two. So go ahead and pause the video and see if you can get these all right. And then I'm going to walk through them as well. All right. This one, it looks like I'm seeing a good lattice point here. Where's another one? Maybe at 2, 0. Let's find out. So I'm going to go up 1, 2, 3, 4, right, 1, 2, 3. So then the other thing I'm going to do, I'm going to see if that is consistent going the other direction. I'm going to go down 1, 2, 3, 4, left 1, 2, 3. Looks good. So we are going up 4. My slope is a positive 4/3 because I was going up 1, 2, 3, 4, right, 1, 2, 3. Our next one, I'm going to go to the right over here. Looks like we've got a decent lattice point maybe at 0, 1. Where's another one? Maybe here at 3, -4. And then I'm going to go up 1, 2, 3, 4, 5, right, 1, 2, 3. So that's -5/3 for my slope. And you can draw your triangle in here. We're going down and to the right. And again, rise over run, -5/3. All right, let's look at number 8. Number 8, we've got good lattice points all the way across that horizontal line. And if I do my rise over my run, well, what's the rise between those 2 points? What kind of rise was between those 2 points? Nothing. What was the run? 1, 2, 3. What's 0 over 3? It's 0. So we're going to write our horizontal line. Horizontal line starts with y equals some constant. What is our y? What are our y values constantly at? They are constantly at y equals what value? 1. And that's our equation. So here was our slope of 0. And then your equation is y equals 1. All right, let's check out 13. Looks like we've got a good lattice point here. And we're going to go up 1, right 2, up 1, right 2, up 1, right 2. So our slope is up 1, right 2. It looks like it's positive. We don't have to reduce. That's all we needed. All right, let's check our next one. So let's pick up 2 good lattice points. Our rise over our run. Our rise between those two is going to be 1, 2, 3. What's our run? Our horizontal distance between those two? Nothing. What is that? That's an undefined slope. And then again, we start our equation with x equals some constant term. What are our x values constantly at? Our x values are constantly at 2, right? So no matter where I put my finger on this line, my x values are constantly at 2. So that's your equation, x equals 2. For our last one, it looks like we've got a good lattice point right here at 0, 3. Where's another good one? We have one almost at 2, 0, but it's not perfectly there. Looks like at maybe 5, -5. All right, so let's come up 5, 6, 7, 8. And then left 1, 2, 3, 4, 5. So our slope looks like it's going to be negative 8/5. Did I count that right? 1, 2, 3, 4, 5, 6, 7, 8, 1, yeah, and then 5. So negative 8/5 is our slope for that one. All right, so we have found out our slope between ordered pairs. We found our slope from a graph. Now let's find our slopes from equations. And then that'll be the end of our video here. So first, we are going to convert. We are going to convert our formula into slope-intercept form. So here's our form of our equation, y equals mx plus b. So slope-intercept form again, our y equals mx plus b. This is our slope, is our m. And our b is our y-intercept of our graph. Then we are going to identify your slope from the formula. We're also going to identify the y-intercept from our formula as well, because we're going to be graphing these things as well. So let's go ahead and identify both. So I'm going to start with number 5 because it's already solved for y. We've already done this first step of convert your formula into slope-intercept form. So it's already in the form of y equals mx plus b. So we have some number for m and some number for b. What is our m? What is our slope? It's negative 7/3. What is our b? What's our b? It's negative 3. But we are going to write it in ordered pair form. And our y-intercept, let me put it up here for you. In ordered pair form is going to be 0, comma b. So let's write it. It's going to be 0, comma whatever our b is. And our b is negative 3. So we're going to fill that in right there. So now let's try number 1 over here. This time we've got to solve our equation for y. So first, let's take our 8x from both sides. Can we combine that with a positive 16? No, 16 is not a like term with 8x. So what we're going to get next, we're going to get 4y equals negative 8x plus 16. Now divide every term by 4. Divide that by 4, that by 4, and this by 4. So that goes away. And we're going to get y equals negative 8 divided by 4 is negative 2x. 16 divided by 4 is 4, so it's going to be plus 4. All right, here's our equation. What's our slope? What's our m? It's right here. It's negative 2. What's our b? It's positive 4. So again, we're going to write it in the form of 0, comma b, and our b happens to be a positive 4 for this equation. So there's our two answers. Our slope is negative 2 and our y-intercept is 0, 4. So just a reminder, when we're graphing these, again, this is our y-intercept. Which one's our y-axis? It's our vertical axis. So we could graph the point 1, 2, 3, 4. And then let's use our slope. We could go down to right 1. Down to right 1, down to right 1, and we could keep graphing. So I'm just kind of previewing that information. Some of you who might remember about the graphing part, that's also a review for you. So I just wanted to throw that info out as well. Just kind of tie all those pieces together. All right, number 2, again, is one that we're going to have to change into or solve for y first. We have to change this into slope-intercept form. So let's subtract our 5x first. And we're going to get 3y equals negative 5x minus 8. Now what? We should divide everything by 3. Let's divide this by 3, this by 3, and this by 3. So then we're going to get y equals negative 5/3 x minus 8/3. And if you wanted to, you could write it as negative 2 2/3. So, or you could write it as y equals negative 5/3 x minus 2 2/3. Totally up to you. This is an or in here for which way. Our slope for this one is going to be, here's our m, it's -5/3. And our y-intercept would be 0. And you can either write it as -8/3, or you can write it as 0 and -2 2/3. So your choice. All right, let's swing over to number 6. Number 6, what's our slope? It's -4. And by the way, I went straight to that because I already saw that it was solved for y. What's our y-intercept? I don't see a b on there. So if it's not on there, you could assume it's just a 0, right? Because it's like -4x plus 0. So if I know that my y-intercept is 0, b, what's our 0? Or sorry, what's our b? I just said it, it's 0. So it's gonna be 0, 0. So on that one, that's kind of confusing. What we're thinking about is our y-intercept is at the origin, 0, 0. Our slope is -4. So this time it's going down 1, 2, 3, 4, right 1. Down 1, 2, 3, 4, right 1. And then you'd graph that line. By the way, you could also go up 4. You could go up 1, 2, 3, 4, left 1. Up 1, 2, 3, 4, left 1. That would work as well. All right, so you guys should pause the video at this point and see if you could finish the last ones by yourself. So pause the video, see if you can get them right, and then come back and check your work. So here again, we're gonna solve for y. I'm gonna add the 7y over. So then we're gonna have 7y. So I'm gonna add the 7y over, and then I'm gonna bring the 4x to the right-hand side. So then I've got 7y equals -4x minus 14. I'm going to divide everything by 7. So then I'm getting y equals -4/7x minus 2. So here's my equation. My slope is this -4/7. And then here's my y-intercept. And it should be at 0, -2. Number 7 is perfect. It's already in my slope-intercept form. So my slope is -3/4. And my y-intercept is going to be 0, 4 1/2. Because it's already in slope-intercept form. So that was perfect. Same thing with number 4. Number 4 is already set up for us. So our slope is -3. And our y-intercept is going to be 0, whatever our b is. And it's going to be 0, -15. And then our last one, it's not in slope-intercept form. So I'm going to get it into slope-intercept form. So this one I've got 5y equals 2x plus 10. Then I'm going to divide everything by 5. So then I'm going to get y equals 2/5 x plus 2. And here's my equation. So my slope is going to be 2/5. And then my y-intercept is a +2. So it's going to be 0, 2. And that is the end of this video. So thanks for tuning in.